Hello everyone, welcome to our channel Mathematics Pathshala. This is a problem of CSIR UGC NET Mathematical Science June 2023. The question ID is 704073. This is a problem of linear algebra. See the problem here. Let us now try to solve this problem. Given that V is a finite dimensional vector space and T1, T2 be two nilpotent operators. That means T1 to the power something, some k equal to null operator, and T2 to the power some say m equal to null operator. Then W1 is given that W1 is the null space of T1 and W2 is the null space of T2. Then which of the following statements are false? So let us check one by one. See first for the option 1. It says that if T1 and T2 are similar, we know the definition of when two operators are said to be similar. There exists a invertible operator P such that T2 equal to P inverse T1 P. This is the definition when T1 and T2 are similar. We also know that when T1 and T2 are similar, then also T1 and T2 are equivalent. T1 and T2 are equivalent. So their rank are same. And we also have rank nullity theorem. That means for an operator T, nullity of T, that means dimension of null space of T plus rank of T, let us denote rank of T by rho T, equal to say first suppose here dimension V equal to n. Dimension V equal to n, and suppose V is the vector space over the field F. So here this will be n, dimension V. So when for this T1 and T2, this rank of T will be same and also this n are same. So null space of T1 will be equal to null space of T2. This is clear. So when that means actually our dimension W1, dimension of null space of T1, that is W1, and null space of T2 means dimension of null space of T2, that means dimension of W2. So since these two vector spaces are over the same field F and their dimension are same, so they are actually isomorphic. They are actually their dimension are same, so they must be isomorphic. Because if suppose this is same as k, the common value, then W1 is isomorphic to F to the power k, and also dimension W2 is isomorphic to F to the power k. So they are isomorphic. This is clear. So this option 1 is actually true, so not false. So we have to find those options which are false. So option 1 is not false, it is true option. Okay, now look at option 2. If W1 W2 are isomorphic vector spaces, then T1 and T2 have same minimal polynomial. So this option actually will not be true. This is a false option. We can give example. Suppose if we take V equal to R3 and T1 equal to say 0, 1, 0, 0, 0, 1, 0, 0, 0, and T2 is defined by 0, 1, 0, 0, 0, 0, 0, 0, 0. So now see here T1 and T2 both are nilpotent, very clear. The eigenvalues of T1 and T2 are both only 0. So they are nilpotent operator. And see here for the operator T1, the minimal polynomial MT1 lambda is clearly lambda cube, because there is only one Jordan block corresponding to the eigenvalue 0, and the size of this Jordan block, largest size is 3. So minimal polynomial, the 0 will appear as 3 times. And see for T2, there are two Jordan blocks corresponding to 0. So the size of largest block is 2. So in minimal polynomial, 0 will appear as 2 times. So this is the minimal polynomial of T2. So see here, the minimal polynomial of T1 and T2 are not same. So W1, W2 may be isomorphic or whatever not. Here, okay. We have to also show that W1 and W2 are isomorphic. So here see, for these two options, we have to also show that nullity of T1 and nullity of T2 are same. See here, actually the if we take V equal to R3 and T1 T2 are operators on R3, then the examples do not work. So let us now take, instead of taking V equal to R3, let us now take this example. For option 2, this is for option 1 and this is for option 2. Let us now take V equal to R4 and T1 is taken as uh, two Jordan blocks of order 2. So first one is this and this by this, and the other elements are 0, and T2 is taken by one Jordan block is of size 3. So this there are 1 and the other elements are 0, and one Jordan block is actually size 1, so 0 simply. So now now see this, clearly these two operators are of rank 2. Here rank of T1 is 2 and also rank of T2 is 2. So by rank nullity theorem, their nullity will be also here same 2. So nullity are same means their dimension of W1 and W2 are same. So dimension W1 will be isomorphic to W2. So this is very clear. So now for option 2, the hypothesis is satisfied, the condition W1 is isomorphic to W2. But see here, the minimal polynomial of T1, that is MT1 lambda, is here there are two Jordan blocks. So the size of largest block is 2, so this is lambda square. And for T2 there are two Jordan blocks of size 3 and 1, so the size of largest block is 3, so this is lambda cube, so they are not same. So see option uh, see here option 2. Here our W1 and W2 are isomorphic, but T1 and T2 have the same minimal, the minimal polynomial of T2 and T2 are not same. So option 2 is not true in general, so option 2 is false. So this is our correct option because this is false. Okay, now look at option 3. This is very clear that if W1 W2 equal to V, then T1 T2 are similar. If W1 W2 equal to V, that means for option 3, when W1 W2 equal to V, that means our T1 W1 equal to V means T1 is 0 operator, and W2 equal to V means T2 is 0 operator. So they are actually same, so must be similar. So is the correct option, so not false. Now look at option 4. If W1 and W2 are isomorphic, then T1 T2 have the same characteristic polynomial. See, W1 and W2 are isomorphic or not, whatever. T1 and T2 are nilpotent operator. So if dimension V equal to n, then characteristic polynomial of T1 must be lambda to the power n, and also characteristic polynomial of T2 must be lambda to the power n, because T1 and T2 are operators on the vector space of dimension n and all eigenvalues are 0. So this is they have same characteristic polynomial. So option 4 is correct option. So here not false. So this is the solution of this problem. Okay. Let us meet again in the next problem. Thanks.